the last operation we need to implement is remove last. Now, before we do this, I actually want to take a step back and think carefully about the user's mental model. What is it we're trying to capture? So let's imagine the user is inserted, as far as they're concerned, 5, 3, 1, 7, 22, and then finally they called add last minus 1. They built this list. So this is more or less what the user's thinking about. Okay. Now the user calls remove last, and what do we expect? Well, we expect that minus 1 goes away. That's the mental model that the user is thinking about. Now, our job as the implementer of this abstract data type, of this list, is that it needs to behave the way the user wants to, and beyond that, it doesn't matter what we do, as long as the behavior is correct. So in this approach, our concrete reality, the actual truth that we have designed, is to use this array to hold all of the information. And at this moment, our goal is to manipulate this concrete reality to match the user's abstract mental model. Okay? Now, there are many ways we could have done it. In fact, in the previous lecture, the actual truth looked nothing like this at all. There was a D list that it was a recursively defined data structure. We did all of that work for that. And that was a totally different way of implementing it. But as far as the user was concerned, the behavior was exactly the same. There's actually a lot of parallels with the Plato's Allegory of the Cave from 2,500 years ago. So the user, the person using the list data structure here, they basically have a specific reality that they can see, that hopefully they can actually interact with, and it behaves in a way that makes sense. We, by contrast, are these monks. We're the implementers. We're one level of abstraction up, and our job is to manipulate these little figures so that the show they're seeing actually matches what they expect. And if they try to, shoot this thing with their finger, like shoot the bird, then this guy's job is to lower the bird and show that the bird has been defeated or whatever. Now, unlike Plato's Allegory of the Cave, where we might imagine using our knowledge to divine the nature of reality and climb out and be free, we do not want to do that as programmers. The person in the cave does not care about the world out here. And in fact, a lot of the progress in computer science is being willfully ignorant about the outside world. That's one of the glorious things about Java. For example, the private keyword says, no, this world is forbidden to you. You are not allowed to see it, and that makes it easier to live the life that you want. So, that said, let's imagine trying to write remove last. So as the manipulators of reality, as those who are charged with changing the concrete representation to match the abstract, what memory boxes actually need to change? Now, one thing I'm going to mention is that the invariants that we've created here, they actually provide us with a guide. They're a set of rules that these characters here can use to manipulate the figures to match the expectations of the user. And as long as we follow these, we should be in good shape. So all of that said, some philosophy aside, try and imagine what memory boxes need to change, and I'll wait here and let you ponder it.